Hello, everyone. Good day to you all. My name is Chris, and I'm very happy to introduce to you our A4Q conference and our first speaker of today. I hope you're all well and healthy. Today is the day, and we start our 4-day-long A4Q World Congress. A lot of exciting speakers are waiting for you with interesting topics. And after the great opening this morning from Mr. Görike and Mr. Henschelchen, I'm very proud to host one of our first speakers of today, Mr. Lovelesh Beeharry. He is the founder and president at MSTQB, an entrepreneur, an automation engineer, and technological enthusiast. Welcome, Mr. Beeharry.
Hello, Grace. Hello, everyone. Thank you for having me here. I'm very glad to be here, actually. I'm looking forward for sharing what we've done with Selenium, actually, with our audience.
Great. And I would like all of you who are watching to please pass your comments, your questions, your greetings into the comment box, and then we will refer to them later on. So I will give the word over to you, and I'm very excited.
All right, great. Thank you, Grace. So, all right, let me, okay. So, all right, hopefully you can see my screen. Great. Okay, so I am Lovelesh. I'm streaming from Mauritius, and today I will be talking about the flexible Selenium test automation framework. And I guess it's time to get started. So today we'll be talking about the Selenium automation engine. Okay, so what's going on in that sector? What's up with Selenium 3.0? There is an automation framework design. We'll be discussing about various automation design that we have for frameworks, and this is where we'll get the presentation will get interesting. Is about the flexible automation test framework. This is the core. This is the core of my presentation, actually, and the upcoming changes that we are planning to make on that framework. And also we'll discuss a bit on the Selenium 4, which is most awaited. We have right now in beta version, but it's coming soon, the 4.0. And we'll end with a session of questions and answers. So without much delay, I would like to introduce myself. So I am Lovelesh Beeharry. I am the founder and the president of MSTQB, which is basically the Mauritian chapter for ISTQB. I am a lead automation test engineer for the NFT team, which is the non-functional testing team at iQera, Indian Ocean. I have around 11 years of experience in software quality industry. I've worked for quite some IT industry in Mauritius. And I'm experienced in manual automation and performance test. In my spare time, I am also an ISTQB trainer and automation framework trainer. All right, so let's get to the interesting part of the presentation, the Selenium automation engine. So Selenium has been there for around 17 years now. It's open source, and we can do scripting on Selenium using different language, C#, Java, Perl, PHP, and so on. And it supports multiple browsers. For example, Firefox, Chrome, Opera, and Headless. Headless as well is very interesting in this sphere. And it comes in different products, actually. Selenium ID, which was known as Selenium Builder before. It's the engine that allows you to record and play test scripts. And it also has the Selenium WebDriver. This is where actually the framework comes into place, where we build on top of the Selenium driver to make it a framework. And we have the Selenium Grid. The Selenium Grid is actually for running the test on different machines in parallel and so on. Selenium is very much popular in the IT industry, in the automation side. So it's the base, or it's being used to extend other automation framework like Serenity, Appium framework, and Robot Automation framework, and much more. There are more frameworks that are in development that are trying to bind itself to the Selenium community. And Selenium comes with a predefined list of interactions like click, double click, send keys, and so on. We'll go into that in the next slide. It's highly flexible, but it should be mastered. I will share a few of of my experience of how we made the automation framework flexible in the company I'm working for. And it's supported by a large community of developers and testers, which makes it a preferred tool for automation. And I'm using Java, so the latest and the most stable build for Java is 3.141.59, which was released like around 2 years back. All right, so that was about Selenium. So the architecture of Selenium 3.0 is something like we have a language binding and a client, a Selenium client, which is connected to the JSON wire protocol and which hands over control to the WebDriver, which interacts with the browser. So this communication happens in two-way. Okay, it's a two-way channel communication. And for the language binding, what I will be describing will be Java. I will be using Selenium Java language binding. And for browser, we can consider Chrome, which is quite popular as well for automation. So like I was saying before, in terms of interactions that we have, so we will write codes in Java like WebDriver that navigate to URL that will be translated into interaction for the WebDriver by the JSON wire protocol. They will basically what it will do, it will take the Java language binding into an API. For example, a navigate to a certain URL is a post API call, and there is a session ID, there is a URL that are passed on as a parameter to the WebDriver. Similarly, for a click event, event, it will be something like WebDriver that find element by a locator. In this case, it's XPath, and we have an XPath expression .click. So this will be in the language binding in Java, and the JSON wire protocol will convert into a post API with a session ID, element ID, and a click. So that's about Selenium 3.0, the architecture, the basic architecture of 3.0 engine. All right, coming up to the framework design. So we have three types of automation framework design, actually, I would say. The first one would be a page pattern automation framework. There are some companies that are still using it. So to understand a framework, we need to know that a framework in itself is a kind of design. We set to manage locators, which would be elements, how we can find elements on the web page, manage the test data, and the automation engine. Once we combine all these three into an object, that becomes a framework, an automation framework. And that framework gives us an automation test control. So considering the page pattern automation framework, let's say we have a web page with a login, username, password, and sign in. So that page will be scripted like a class within the framework, within a page pattern framework. That's the login page class. And the interaction that we can do within that page will be in terms of methods. For example, login method. So in this case, we have login as a method that as an interaction that we can do on the login page. We have the locator. For example, in this case, we are looking for the locator by its name. The name is username. We are looking for this text box actually that has an attribute called name. And we are looking for that username, and we are sending a certain value, which is the test data over here, Lovelesh. We are sending it down into that text box. Similarly, we are doing the same for the password, and we are trying to click on the sign in. So this is a signing process in the page pattern automation framework. The problem with this is automation in this sense is quite technical. So we need people who understand programming, who can script, who can write codes to do the automation. And it's quite restricted actually to have such a page pattern automation framework and have it open to manual testers. And also this kind of framework is quite prone to heavy maintenance. Wherever there is a test data that need to be maintained or a locator that need to be maintained, it's quite tricky actually to do it in such framework. So the next one is data-driven automation framework. So we've extended the concept of page pattern. What we've done is we've extracted the test data. So in this case, we've extracted it into an Excel file we make the framework read from the Excel. They read the username and the password, and they try to input it into the web page. The advantage of having such kind of framework is we are able to write the locators into the code, and the manual testers are able to contribute as well by doing the test data maintenance. So they are required only to just update the Excel to maintain their test data. But still, the locators are inside the code. To write test cases, we still need to be technical. So to compensate for that limitation of data-driven, we explore the keyword-driven automation framework. This one, what it does is actually externalize the most of the items that we need to write a test case. So to write a test case, we need an action like enter text or click. We need a locator on which item we want to enter a text, and we need a test data, what text to enter on that text box. So based on that concept, actually, we can externalize the action, the identifying the test data, into an Excel file. It can be an Excel, it can be an XML, which is something outside the code. And the manual tester is able to write test cases in Excel, and we will just execute the executable for the automation framework just to carry out the test case. So we will be actually drilling more into the keyword-driven automation framework, and we'll see how we'll make it more flexible. Okay, so what do I understand by flexible? What do I mean actually by a flexible automation test framework? Well, a flexible automation test framework for me is something that we can add features. It's something that is easy to maintain first. It is something that we can add additional interaction, additional features onto the code, so that it can do more test cases. It can automate few things that they initially were not able to do, and also it's a framework that will code once and will be available to multiple products. So it's only one framework that we can write test cases in different Excel, and we plug that Excel onto the framework, and we'll run the test on different products. Okay. So how we made actually the automation framework that we have more flexible to the manual testers, we've created a pseudo programming language. So with the pseudo programming language, the manual tester are able to create their own variables within the Excel and plug it into our framework, and the framework will actually create those variables at runtime. We'll get into that in more detail. They can retrieve the variables as well. We have provided a mechanism for the manual testers to loop over the test cases, so that they don't need to write test cases, copy paste test cases over and over again. So they can loop over the test cases with different parameters. They can do SQL query in the Excel itself. So they write the SQL query, and when they run the framework, they will actually give them the result of the query, and they can use that result for further test cases. They can generate random values. They can do API call. All these are defined in the Excel, and the Excel is plugged into the automation framework, and it is executed. So the manual testers are very much able to help us in automation testing. They actually drive our increase in test coverage. They are able to help us in writing test cases, and we concentrate on maintaining the coding side of the framework, adding new features and so on. Our framework is cross-browser and platform independent. What I mean by that is it's based on Java and Maven framework, and so we are able to run it on Windows machine. We are able to run it on Linux as well, and we are able to run it on different browsers, even headless. Yeah. So that's the concept of having an automation framework which is flexible. So this is a bit higher level picture of our structure, of how the automation framework is actually organized. We'll have the manual testers, which is outside the automation framework. This is the delimiter for the automation framework. We have the Excel, which is also outside the automation framework. Inside the framework, we have an Excel reader that will read the Excel file. We have a token interpreter. For right now, we can let's take token to be something like a dynamic variable that the manual tester is able to define in the Excel. So we have an Excel reader that can hand over control to the token interpreter and the controller. The token interpreter will do all the necessary conversion to create dynamic variables and so on, and hand over control to the executor. The executor will then interact with the Selenium core, which is basically the JSON wire protocol and the WebDriver together, and they will actually interact with the browser, where the automation steps will be carried out, and the browser will give a feedback to the framework again through the controller, and the controller is able to report it to the tester. How it's reported is reported in real time with a console and an HTML file. So the HTML file is like a report having screenshot and so on about where it failed and which step passed and so on. And that HTML report is actually compressed, and we send it by email as well to the team, so they are able to follow up about which test case they've run, which test case pass and fail and so on. So we need to analyze which one is false positive and which one are really bugs to log it. The executor also have access to the database, to the platform database, to batch job and Elasticsearch. So we are able to run jobs through API call, which are defined in the Excel through the executor. We're able to run queries as well in the Excel through the executor and get the response and carry on the test. So that's basically the structure of the framework itself. All right, so a major part of our framework relies on the test sheet. So in this test sheet, actually, we define the test cases. We have a test case ID, we have a test step, and we also have a scenario, we have the test that we are doing, and actions. This is the action that we've externalized. These are interaction for Selenium that we've externalized it. And we have the locator type. We can do by XPath, by name, by ID, and so on. So this is the property that we use. We have the XPath, the locator itself, and we have the test data. Okay, so this is how a test case looks like in the Excel file. And now we need to sequence those test cases into test suite so that they are executed in a certain order and the test is carried out. So we need another sheet, which is the test suite. It is in the same Excel. So we have a test suite ID, we have a test suite name, objective, and the test cases. The test cases are sequenced one after the other, separated by comma. We have a toggle, whether it is to be executed yes or no. We have the platform on which we want to execute it. We can execute it on Chrome, Firefox, Edge, headless. We have a base URL where we want to navigate and start, and the email is configured over here. At the end, when the test is carried out, the framework will send an email over this address. All right, so that was about the test data. Now let's dive into the flexible automation framework. Well, to build a flexible automation framework, the locators must be strong. In our case, we've chosen to use XPath as locator. Why? Because other locators like name, class, all those attributes actually can be built into an XPath expression. For example, we have name over here. That's an attribute name. And we have an attribute value as username. So we could do like find by name in Java and have it like a username over there. Or we could build it like an XPath expression, which gives us more flexibility. So to build a strong XPath, we need a relative XPath. We don't use the absolute one because those absolute, we start from the HTML, we drill down to the actual value, to the actual element that we are looking for, and that's quite tricky because if there is something that is updated in the page, the whole XPath actually will no longer be valid. So one advice is to use actually relative XPath. We make use of extensive XPath functions like contains, like not. Those are certain ways that we find to actually make the XPath more flexible. And as far as possible, we use clear and concise XPath expression. For example, we have contains at type SBM SUBM. So this type is actually submit over here, but given that it contains the string SUBM, it will still be valid. Let's say tomorrow we just there is an update in the web page. We just write submit 1 or submit 2, or we just remove I and T from it. This export will still be valid. So that's one maintenance less. And in the other example, the second example, we have an OR. So this is using conjunction. In one of our product, we have a login page on one environment, which is a simple login like a username, password, and a sign-in button. All everything is being handled internally within the software. And on another environment, which is this environment B, we have a complex login which is linked to a single sign-on mechanism. So the export over there are different, but the product is the same. So we write export in this way with OR conjunction in the expression itself, so that we have only one test case for the same product on two different environments, although the export are different. So this is one way as well we've cut down on writing excessive test cases without impacting the test coverage. Okay, and the last one is actually the not symbol, actually the not keyword, is to actually look for element that is not containing a certain value. This is quite handy from time to time actually to build a strong export. Okay, there is other ways as well. These are these two examples are actually ways for extracting export. We do in the last result where we are not able to extract and export in a clear and concise way. So we use the position keyword. The position keyword, what it does is it actually take element that are defined by a certain position in the export. In this case, it's position less than 3. So it will select the first two elements that this export describe. And we also make use of export access. Access include sibling, parents, ancestors. So in this case, we have one element, which is the current node, and we have the ancestor node. We are looking to move up from one element. We are looking to move to its container. So this is the way that we implement it. Well, these two actually we use it in extreme cases where we're not able to get a clear and concise export. All right, so the second ways we can make an automation framework flexible is not to use only base our test solely on the Selenium interaction. From time to time, it's quite complex. Let's say we are trying to click on an item that's pretty much straightforward. We are trying to wait for an element to appear. This is where it becomes a bit tricky. So we've devised custom methods that help us to do that. For example, there is a wait item load. We still use the Selenium interaction within the methods, but we've changed those action a bit to make it suit our product. The product that we are actually automating at iQera it's quite tricky. It's quite tricky because there are some toggles that JavaScript gave us. And those are overridden by the codes of the program itself. So we are not able to use like page.ready or to use the flag that is given by the browser whether the page is ready for interaction or not. So we need ways to fight those difficulties. So one thing that we've done is we've defined an action called wait item load. What it does is we give in an export in the Excel. And once this export is, the framework actually tries to find this export. If it doesn't find it, it will wait for a certain time that we define in the Excel as well. We'll try it again, like 5-10 times. So that's also flexible as well. If it doesn't find it at all, it will fail the test step and move on. If it finds it, it will stop and move on. So this helps us to save time and also help us to avoid static wait. What I mean by static wait is like to tell the framework, okay, wait for 10 seconds. This might work for one environment, but once we move to the other environment, the infrastructure is different. It might take 20 seconds over there, and all the subsequent tests will fail. So this is like a dynamic way that we've implemented. Repeated click, that's another method that we've developed for our framework. What it does is we give in an XPath expression that not necessarily define only one item on the page. It may define multiple items, and it will click one after the other on those items. So this is quite handy when on one of our product we have to log in. When we log in, we have on the dashboard we have multiple windows that are open, and we need a way like to close those windows. And the problem is that the small windows that are open are dependent on the user. That is, it is configurable on the user level. So for one user, we may have like 10. For other user, we may have 3. So repeated click is dynamic in the sense that we have an XPath that describes all the close button for the windows, and the automation will close those as long as those buttons are still present. It will click one after the other and close all the windows. And the last another example, the last example for the custom method that we've developed is the wait item to disappear. What it does is actually when we click on let's say we are trying to create a user, we click on save button, we get an overlay which says that the action was successfully completed, the data is being saved, and that overlay will disappear, will take some time and disappear and fade out. So the system doesn't become interactable once this overlay is present. Because it covers certain items that we might need to interact. So we need to wait for that item to load, to disappear actually, and we can continue with our test. So this is ways that we've devised custom methods, wrapping the Selenium interaction within those methods and made it open to manual testers to use in the Excel. All right, so this is also an interesting concept that we've come forward. During our test, actually, we needed to find a way to store values that are on the web page, on the web app. Okay, so to store it, and we'll use it in subsequent tests. Okay, let's say we created a user, we need to store that username later on because we are trying to automate as well to modify the created user, to modify the information of the created user. So this is where we came forward with token. Our initial approach was a bit different. We started with writing, like, within the framework, we hard-coded like 10 variables and made it open to the manual test team. They started using it. Within a week, the 10 variables were depleted. They used all those variables. So we said, okay, let's create 30 variables. We created 30, and again in a week we ran short of variables. As our test coverage were increasing, we needed more variables. At a certain point, we had even like 90 variables created in the framework, but it's not sustainable. This model is not sustainable. What we've done, we've devised a way that we can create variables through the Excel at the user demand. So now we have unlimited variables. The user can define which variable name they want, which variable type they want to have as well, and which value they want to store it in it. And in this way, we are able to actually create multiple variables, unlimited variables within our framework. So I would break actually those variables, we term it as automation tokens, into 4 categories. The first category is the one that generate dynamic variables, for example, random variable, and the other one is a timestamp. These two generate values. Random, let's say we want to generate a certain set of characters, letters, and numbers in it. We can use run. At times, it becomes handy to do that. And timestamp, when we want to create unique values in the system. Let's say we want to create ID in a system, so that become handy as well in the timestamp with the timestamp token. And when we want to store single values, single variable, let's say like we want to store a name or a surname somewhere, we can use the single variable token, which can be of type string, integer, currency, or boolean. And we've extended that concept of single variable to a list of variables. So if we want to run a query on a database and store the whole data set into different variables, and we'll use those data set later on. So that's possible as well with list of variables. So we have store in list, that's the action. And we have string list, integer list, currency list, and Boolean list. So far, these 4 types we have been able to automate our tests so far with these 4 types. If ever we need more variable type, we can plug it in. And that's a characteristic of having a flexible framework. And storing those values are good, but we might also need to retrieve those values. So we need a reference, a way to refer to those variables. And this is the reference token. Okay, so to dive into more into the automation token. So these are the syntax, how we've designed automation tokens to be. We start with curly brace. We have the keyword and a greater sign, and devise a certain like a pattern. Okay, for the random one, let's take for the random token, we have user underscore run greater than a certain string. So it will create, the user will stay the same because it's outside the token. Over here, this value will be replaced by its corresponding random characters. For capital letters, will stay capital letters. For those in lower cases, will stay in lowercase. And the numbers 99 will be generated at runtime. Each time we run the test for random, it will be different. This is handy when we want to create items of which are unique, but they can't support timestamp in it. So let's say we need to create an ID with free characters. So this is where random token comes into play. We have also the timestamp. We define the format. The format is based on the Java library, so we can change the format, play around with the format, and it gives us the corresponding value during the runtime. And this is the integer token. So what we are trying to do over here is we are defining a variable called num underscore items of integer type, and we are trying to store a certain value in that variable. So it creates and store value in the integer variable num underscore item. And when we are trying to retrieve that value back into the test case, so we have to use the reference greater than integer greater than the variable name, and it pulls the value from that variable. These 2 are example of how we implement these actually. So in a test case, we are trying to enter a random value in a text box. So we have the action enter text. Okay, we use an xpath as a locator. We use an xpath expression to locate the element that we want to interact with, and we use the test data as this. So it will create a user underscore a certain like a free character random generated the values. Okay, and this will be entered in that text box, and we can run the test over and over again. And the second example, actually we are trying to store a number in a token, but look at the xpath. The xpath also has a token. So this is why we need in the framework, we need a token interpreter. So the token can be used in values, in test data as well, in value colon and test data in the xpath as well. It works. So the text is being stored in a subsequent test. In a previous test, we are storing a value string text name. We are building an xpath on top of that. We are extracting the span text, and we are storing it in a variable called num underscore item, which is of integer type. So this makes the test a bit dynamic, and we also don't need actually to maintain these xpath as long as the structure of the page is maintained. Right. So now extending that variable into the list. So string list. What it does, string list greater than name, it stores a certain name on a string list, and the reference is actually we are trying to extract the names from that string list called names. its implementation. Okay, we have certain values that we want to store in a list, one after the other. So we have Bruce, Clark, Barry, and Al. We are storing those values into names, into the variable names. And when we are trying to retrieve it, we can use the reference string list that greater than name. And we are doing something interesting as well over here. This is for string operation action. What we are trying to do is to replace the capital letter A with E for all the names that we have in the list. We can do that as well, and we store the resulting values into a new variable, which is new names. So all the names, they replace with a single line of the test case. With a single test step, we can replace the value and pull all the values into a new string list variable, or we can replace it in the same names. What it will do, it will just replace it, destroy that string list, and save those items again back into the same list. That's dependent on the manual tester, the way that the test is being carried out. Okay, so the implementation of those automation token. Well, coming with that concept, we actually have to dive back to C programming language. How it happens over there is actually we have to store variables. We have a key and the variable value. We have a key and the variable value. It's in a linked list. And the similar concept is for string lists, where we have a key and a set of variables. Those variables are defined as an array, which is not bound actually by a certain index. So these arrays are actually initialized, instantiated during runtime. So this is the implementation. We have also implemented the conditional step. What it does is conditional. Let's take for example conditional click. If it finds this XPath, it click on this XPath. Why we need these? Actually, these are fallback strategy or recovery strategy. When we are doing the test, there are times when there is an unexpected pop-up that appears. For example, we are trying to save something and there is a network glitch. There is some latency in the network, and there is a pop-up that appears that if you try to navigate away, you will lose all unsaved changes. So we need a way to handle those things, because if we don't handle it, all the subsequent tests will fail. So this is where conditional click actually come into play. And we also need to make sure that there is one fail step in the report that will help us to replicate the issue. We have to confirm still it is not a false positive, or if it is a false positive, or if it is a bug. So that's the aim of having conditional click. Similarly, in a conditional step, we have skip if false. If this XPath is present, we will skip 2 lines of test. So it will, let's say this is the first line, we'll skip the second and the third, and we'll continue execution on the 4th line. So this is quite handy as well when we have pages which are dynamic. So let's say a user with different user role. Some have more options, some have less options. So in only one test case, we can cater for all these with the skip if false. Okay, so another structure that we've set into place is to sustain looping. What I mean by looping is actually we can write only one test case and loop over that test case over and over again. This helps us to avoid duplication. We just don't copy the test case TC001 again and again, because this will induce more time for maintenance. And that's something that we want to cut down. So what we do is we have a structure, we have an action called loop, and we have a string list as reference. So the string list in itself is defined in the previous test, and we are trying to store usernames. So standard user, locked out user, problem user. We are trying to store those. We are storing those in this token, in this variable, and the loop will be done till this list is not exhausted. So it will be done 1, 2, 3, 4 times. It will be repeated 4 times. It will navigate. It will wait for an item to load. It will enter the text. Click. So in this test case, we are trying to check if the user are able to log in, and we do it in a loop, in a loop sequence. This is quite handy when we let's say we want to check if 500 users are able to log in on the platform. So we just do it in 2 test cases. We write it quite simple. Okay, a spice of randomness. This is also interesting actually. What we wanted to do with our automation framework is not to use the same entity on the platform to actually do the test. Let's say we are creating a user and we are modifying a user. So for modification of the user, we just input the user that they want to modify. Okay. Each time we will run the test, the same modification will be done over and over again for the same user. So we wanted to find a way where the automation framework could randomly pick a certain entity and do the modification or do certain tests on them. So this is where actually we've implemented the action click on random item, and actually this X is a keyword in the square bracket. It will actually generate a number based on the first X path. The first one will give a count of how many items are present on the web page. It will generate a number between 0 and this count, and that number will be replaced in X, and the implementation in the code is shown above. Okay, database connection. In this case, actually, we can run queries as well in the database. We just write the query, okay, tokens inside as well in this query, and the framework will run the query, store the value that is returned by this query into a variable. It can be one single variable, or it can be a variable list as well. That's the database connection. We can run API call. We've implemented the method add header, add body, and do the API and the properties post. We can also do like a get property, a get API call. We use token extensively in those items. We can run query on the database, get item from the database, get elements from the database, plug it into the API call, and run the API call, and get the JSON response from the API call, extract those value from the API call as well, and use it for subsequent test. So that's quite interesting way of actually blending database API and functional test together. Right. So the implementation of the header and the body is the same as the variables that we've used, the token implementation. So that's shown over here down. Okay, comparison and calculation. That's also something that we use extensively in our framework. iQera deals with in the world of finance. It deals with a lot of figures. So we need a way like to compare values, okay, to do a certain calculation. So that's implemented in this way where we can do compare calculation, and then there is a token. We do a certain calculation like minus 10 out of it, and we compare it with a value over here. In this case, let's say we are trying to compare a card price. We added few items and we remove few, and we are just trying to make sure that the number we remove and the one that is displayed on the page, they are matching. So that's another way of implementing it in the Excel. We can do the same calculation on date time. So we have timestamp over here in the year. We +1, it becomes the next year. And something new that we've interested, something new that we've implemented that is interesting and saving quite some time actually. There was a scenario where we had to extract details from a database, run a job, and then compare the new details in the database with the old one. We had to flag all the discrepancies that we found. Well, that is easy to do if we have a list of like 10 items, 20 items, but in the database it was 140. So it was taking like, and it was not sequence as well. So it was taking like half a day or more to do that. And we've implemented the compare action for lists, and we are talking around 140,000 records that are extracted, and we are able to do that comparison within like 100 seconds instead of 2 days. So that's quite some time saving over here. Okay, so that was how we implemented actually flexibility in our framework. What's coming more actually in our framework is the self-healing part. The self-healing part is interesting. It means that if there is an XPath or there is a locator which is not found by the framework, the framework can understand. Okay, it try to heal from that situation. It try to find another locator that will suit that element. So for that, we are actually implementing the Selenium. That was a few weeks actually. We started looking into that, and we did a proof of concept on this, and we are implementing it in our framework now. So we'll go in detail in Selenium in the next slide, and the rest are pretty much standard actually. For failed test cases, actually we are taking screenshot for now, but that may not be enough actually to drill down to the root cause. So we are, for failed test cases, we are doing a screen recording as well. That will help us to drill down to the root cause. We are trying to upload our report to SharePoint, because once we are sending it by email, we are limited by the SMTP limit, which is 25 MB for email. If we have lots of screenshot and if it exceeds 25 MB, the email will not be sent. So we are trying to upload the report into SharePoint, and we are also trying to implement the retry logic for failed test cases. Let's say we have a suite of test cases that there are few test cases that are failing in that, and we are trying to execute those test cases again at the end of the test suite, so that we can confirm whether when we have two runs actually of the same test case, it gives us a better view whether it's a false positive or it's a bug. And lastly, we are trying also to get statistics out of the automation framework. For all the runs that we are doing, we are trying to classify those runs, those test cases into functionalities, to modules. This way, we will know on which modules we have more problems, and where we need to drive the test coverage, where we need to have more test cases written, so that we can ensure quality over there as well. Right, so that was about the upcoming updates. Let's dive into the Selenium side. That's an interesting framework actually. It's worked with Java. So far it works with Java and Maven framework. There is also a President framework that works well with it. How it happens, it's actually there is an element that we are trying to find. It finds it. When it finds, it goes to this dependency and it's saved in the backend. There is its own database and so on. Saved. When it's not found, when an element is not found, it will go to the tree comparison. It will extract previously found locator, and it will generate a new locator. And the new locator will be sent to the framework, and the framework will click on the items we want to. So that's interesting because it will cut down maintenance for sure. And the other thing that is interesting with this is actually it's based on probability. So let's say we are looking for this button. Once it was done successfully, it is saved here. The button properties attribute changes. The XPath is no longer valid. We send it to the Selenium side, and it based itself in finding a good locator based on probability, and that's configurable as well. We can say, okay, let's say it's password. The item that we had initially was password, and it changed to password text. Okay, so there is an internal mechanism to calculate whether password text is the same item that we were referring to before as password, and it generates a probability, and based on that probability we give a new XPath, and the framework will be able to heal from that wrong XPath. And it generates a report as well, so that you can actually maintain those XPath, but it won't fail your test. So that's positive. And this is very important as well for us at iQera, because we have products that over which we are running automation tests like for 17 hours in a row. Okay, so we have tests we are designed that if we run it sequentially, will take 17 hours. So if there is something that is that is failing in between, it will definitely impact some test cases. So Selenium is a good tool that will help us minimize those impact. So in the square, you will see the Maven dependency that you can include in the pom.xml file, and we'll download that Selenium framework. And also over here, you can see how it's implemented in the initialize for the Chrome driver. So there is another driver which runs in the background for the self-healing driver that keep track of which locator means what, and it does the saving into the backend for the Selenium database. Right. Okay, so that was about Selenium. Let's talk a bit about Selenium 4.0. So around a month back, there was Selenium 4.0 beta 2 was released. So that's actually a breakthrough in automation, because we now no longer have the JSON wire protocol. Why we removed it? It actually the main concept of having it removed was to create a stability and certain standardization in Selenium. So W3C is a standard that was developed for online interaction using browsers and so on. So Selenium is getting onto that standard, and the JSON wire protocol was kind of adding certain level of difficulty to get standardized. So Selenium 4.0 will allow stability, and it will allow standardization. With this standardization, actually something very important comes for automation testers is the seamless cross-browser. What I mean by that is an interaction between Java and Chrome. Let's take for example Click is implemented in some way, but for Firefox it might be a bit different. It might be a bit offbeat, or it might be a bit tricky, like to just imitate that action. So with that standardization, the cross-browser scripting will be more intuitive. So we write the code once, and we can just change the browser without changing the code, and it will run still. And another beauty of that is it's backward compatible. What I mean by backward compatible, it's that if you don't want to use Selenium 4.0 but you install it and you're still using the JSON wire protocol, that's fine. It will still work. Right, that was about Selenium 4.0 and the major changes that are happening in the Selenium world. So this brings me actually to introduce you to the NFT team. Actually, these guys are in my team, and they had a very important role actually to set the framework, to bring the framework where we are right now, the automation framework. And also, I would like to introduce you to the MSTQB team, and this team is actually working hard to bring the testing community to international standard, and we're trying to leverage the community here in Mauritius. Right, so this brings me to the end. So I thank you for your time, and I'm now open to your questions. Well, yeah. I managed it within 1 hour.
First of all, right. Thank you so much for this awesome presentation. We do have a few questions over here, so I will just pop them in there. First from Emna, she's from Tunisia. What are the design patterns you recommend the most for Selenium-based tests?
Well, design patterns, actually, any design pattern that will actually open the test to manual testers. The fear of testers that are not quite technical into programming is that they are not able to contribute to automation. So any pattern test, like the keyword driven, is one design that can help. That is actually fruitful to the team, because the automation, if the automation team is to write test cases, is to maintain the framework, is to add new features to the framework, then we'll need a greater team. And this is not very productive in that sense. It's not very valuable in that sense to grow a team more than the manual testers. The aim over here is the manual testers are expert in the product. They know the product better. The automation test team is more technical. They know the technology better. So there need to be a blend. And we as automation tester, we have the responsibility of following one concept. We absorb all the complexities within our code to make the work of manual testers easy. For example, writing of test cases, we make it easy through Excel, through simple codes for simple syntax, and they will be able to onboard with us in driving the test coverage, increasing the test coverage, while we maintain the framework behind and add new features that will help them in the test. Well, the token design was a design that we came up with. There can be other design that will work the same, like we've devised the automation token. So those designs are important to keep in mind when we are trying to build a framework. Yes, that was I think pretty much the answer I had. Yeah.
I hope that answered your question, Emna. And we have another one from Edgar. Edgar is from Lithuania. So we see we have a lot of international watches over here. So Edgar, what library you are using to read from Excel and using the code?
Well, okay. When we say Excel, actually, we need to understand that Excel is being saved in an XML format in the background. Okay, so right now we are using the Apache library. The sublibrary is the POI, Apache POI. That's the Excel. That's the equivalent of an Excel reader for Java. So what Apache POI does is actually go to the XML structure itself and try to extract information. And XML being the basis for Excel, and that works for Excel as well. Yeah. The only thing that we need to be careful about is Apache POI is not very intelligent in a way to in a certain column. We might need a single type of values. For example, let's say we are entering 1, 2, 3, and we are entering a name over there. So Apache POI will not know whether it's a numerical value or it's a string value. So we need to convert those numerical value into a string, and then we handle that complexity in our code. How we do that? We just input code, a single code within the before those numerical values, and it will be converted into a string. And it works perfectly with Apache POI to read from Excel in that way.
Okay. There's a couple more questions, but there's a lot of thanks and excellent presentation, perfect presentation. So the people really enjoyed it. Maybe we can close with one last one because time flies. Do you use dev tools to check errors in console for automated tests?
All right. So yes, we actually, that's an interesting question. So in the console, we usually get error 400, error 500, and these are actually very useful for us to find bugs. We've devised one method called scan for errors. What it does, it scans all the 4XX errors, 400, 4004, and so on, all those errors, and also the 5XX errors, like the error 500, the server is down, error 503. So we have actually, the way it works is Selenium keeps a bucket. We need to all the API calls that are done in the background actually fill or fed into that bucket, and we need to scan that bucket regularly. Once we spot the error 400 and 500, we just flag it out, and it's done in the automation framework. So we have an action. We've implemented that action. The action is called scan for errors, and it is at the end of all our test cases. So every interaction we do, we scan the bucket. So in this case, we don't need actually a dev tool because it's already on board our framework.
Okay, awesome. So we're out of time. Thank you so much for your presentation and your time. It was very interesting. It was a very interesting, exciting start into this whole week. So I wish you all the best. It was nice meeting you.
Thank you, Chris.
And thank you all for watching. And please keep updated and watch the other 3 days as well. And we keep in touch. Thank you, Lovelesh.
Thank you, Chris. Thank you, everyone.
See ya. Bye-bye.
Stay safe.